Good morning, students. Students, this lesson is of class 10th for the subject of physics. Topic: moment of a force and equilibrium, which is covered in chapter 1, force, of your physics textbook titled Concise Physics by Selena Publications, and is being submitted to you on 5th April 2021. Students, before starting today's topic, I want you all to push a chair or a table nearby you. Name the quantity which you are applying to move such objects. Students, kindly write down the name of quantity and its SI and CGS unit in your physics notebook, and also write the relation between both the units. You may pause this interactive session for 5 minutes, and after writing the answer, you may resume the lesson and you can check your answer further. Now, I hope you all must have written the answer, and now you cross check your answers. The quantity here used is force. For pushing an object, what are you applying? You are applying force. And the SI unit of force is newtons, while the CGS unit is dynes. Children, we studied about force in class 9th also. So the SI unit of force is newtons, while CGS unit of force is dynes, and 1 Newton is equal to 10 raised to power 5 dynes. Children, as we have learned in class 9th, that force can be defined as rate of change of linear momentum. What is force? Force can be defined as rate of change of linear momentum, and it is a vector quantity. Force is a vector quantity, and mathematically the formula of force can be written as force is equal to ratio of linear momentum with respect to time. Where this triangle stands for? The triangle stands for change. Change in linear momentum. P is linear momentum. Triangle stands for change. T stands for time. And children, as you might remember, the formula of linear momentum P can be written as product of mass and velocity of an object. Similarly, we did gravitation units of force also. So the gravitational units of force are kgf, that means kilogram force, and gf, which means gram force. 1 kilogram force is equal to g newtons. G is acceleration due to gravity, and we have to find the answer in newtons. So g newtons, g will be here, 9.8. If I talk about SI units, in SI unit, small g is 9.8 meter per second square. But children, if we write down in CGS unit, the value of g will be 980 centimeter per second square. So 1 kgf is equal to g newtons, and here g will be taken as 9.8 newton, and 1 gram force is equal to g dynes. Dynes is CGS unit, g dynes, and the value of g will be, now take the system in CGS. So the value of g will be 980 dynes. So just two things has to be remembered. Firstly, that 1 kilogram force is equal to 9.8 Newton, while 1 gram force 980 dynes. So these relationships has to be learned among the various conversions. So children, now let us start with our main topic, that is effect of force on a rigid body. Now children, whenever a rigid body is acted upon by a force, it can have two kinds of motion, namely translational motion and secondly rotational motion. So whenever a rigid body is being applied a force, that force can bring two kinds of motion, translational or rotational. Now first let us discuss translational motion. Children, kindly see figure number 1. I have made a horizontal surface on which there is a ball which is moving along positive x direction. The children, if I push this ball, originally this ball was at rest. Originally the ball was at rest. And when I applied a force in x direction, suppose let us apply a force on x direction, that means I'm pushing the ball in the forward direction. The ball start moving in the forward direction. So this is the direction of motion also. So children, if we push a ball towards right side, the ball will begin to move along the same right direction. Similarly, if we push a box lying on a floor in a forward direction, the box will start to move in the same forward direction. So what can we conclude from here? It can be concluded that when a force acts on a stationary rigid body, stationary means when the body is at rest. So when a force acts on a stationary rigid body which is free to move, the body is free to move in any direction, that body starts moving in a straight path. That body starts moving in a straight path in the direction of force. In the direction of force. This is called linear or translational motion. Next comes rotational motion. Now children, if a body is pivoted at a point, that means it is fixed at a particular point, and a force is applied on the body at a suitable point, then the body rotates about the axis passing through the pivoted point. If you fix a body from a particular point and apply a force at any other suitable point, then the body does not move freely since it is fixed from one point, but the body starts rotating on its axis. And what are that axis? That axis must be passing through the pivoted point. This is known as the turning effect of the force, and the motion of the body is called rotational motion. Now children, for example, when a force is applied normally, that means perpendicularly, on the handle of a door, the door begins to rotate about an axis passing through the hinges on which the door rests. So children, kindly see figure number 2. In figure number 2, we will be applying a force at the knob of the door. So this is the door, the knob of the door. Pull this door towards yourself. This is the direction of force applied. When you are pulling it towards yourself, the direction of force is this, towards yourself. And when you are pushing it away, again you are pushing it away from the handle only, and then the force applied is away from you. So right now we are pulling the door towards ourselves. Children, kindly see the door nearby you. You will see 2 hinges. It can be 3 also, and that hinges act as the pivoted point. The door is fixed with the wall. This is the wall here. Suppose this is the wall, while the other thing is your door. Now what happens here? This door has to be fixed with the wall. But how? So how we have pivoted it? We are placing some hinges such that the door is fixed with the wall. Whenever you are applying the force, either pull or push, the door rotates along the axis of rotation, that is, along the hinges. So now let us study further, that is, moment of a force, which is also known as torque. Moment, it is not movement, it is moment. Moment of a force, also known as torque. See the spellings of torque. T-O-R-Q-U-E, torque. Now children, on a body, the turning effect of a force depends on 2 things. the turning effect, that means torque depends on two things. Firstly, magnitude of force applied. That means how much force you are applying. Magnitude. Magnitude of force applied. And secondly, the perpendicular distance of line of action of the force from the axis of rotation. Children, just listen carefully. Sometimes when the factors are asked, we usually write that torque depends on magnitude of force and the perpendicular distance. This statement is incorrect. Why so? Because distance is between two quantities. So you have to write down this distance is between which quantities. So the perpendicular distance of line of action of force and the axis of rotation. For example, in figure number 2, this, when you are pulling it yourself, this is your line of action of force and this is your axis of rotation and the perpendicular distance between these two. Suppose this is R and the force applied is F. So torque will depend upon this R and F. Basically, torque is product of R and F. So what is this R? R is the perpendicular distance between the line of action of force and axis of rotation or the pivoted point. So further, the product of both R and F is known as moment of force. The product of both R and F is known as moment of force or torque. Thus, the moment of force is equal to product of magnitude of force and perpendicular distance of line of action of force from the axis of rotation. And mathematically, torque can be written as force multiplied by perpendicular distance. Children, the symbol of torque is already shown in your PDF notes. It has to be written like this: a horizontal line, and then you can say it is like just C only, half of the C. This symbol is having a name. This is known as tau. It is known as tau. So whenever I am saying tau, this is a Greek symbol and it will represent a torque. Don't write down T. T stands for, capital T is for temperature. Small t, we take it for time. So torque is taken as tau. It is also a vector quantity. Torque is a vector quantity. Now, the formula of torque is R multiplied by F. And if I talk about the units, R is distance. It will be measured in meters. F is force. It will be measured in newtons. So when we are writing the SI unit of torque, we will be writing it as Nm, Newton meter. No need to put a sign of multiplication. We can simply say Newton meter. Children, Since you are having a habit of writing meter per second square, similarly, kindly don't write Newton per meter. This is wrong. It is not division. It is not Newton per meter. Rather, it is Newton multiplied by meter. And if we write down m into n, meter into Newton, this is a wrong way to write. You can't say mn. Why? Because children, m multiplied by n, it can be said as millinewton also. Because small m means milli. So m into n represents millinewton. Thus, if I want to write down torque, I will write down its units as Newton into meter. Continuing further, students, since you know how to do conversions now, you may please pause this interactive session and then write down the CGS units of torque and hence derive the relationship between both SI and CGS system of unit. And after completing the answer, you may all continue to resume the lesson further and check your answers. Now I hope you must have written the derivation part. So let us see the relation. First of all, CGS unit of torque is dyne multiplied by centimeter. Dyne multiplied by centimeter. And if I write down the conversion, the relation between Newton meter and dyne centimeter. So children, first of all, 1 Newton meter can be said as 1 Newton multiplied by 1 meter. Since we have already learned today also that 1 Newton means, what do we mean by 1 Newton? 10 raised to power 5 dynes. While in 1 meter, we are having 100 centimeter. 100 means 10 raised to power 2 centimeter. So 1 Newton meter can be written as 1 Newton can be written as 10 raised to power 5 dynes multiplied by 1 meter can be written as 10 raised to power 2 centimeter. So 1 Newton meter is equal to, how many powers are there now? Since it is multiplication, the powers gets added up if your base is same. You have done this in exponents in mathematics also. So when the bases are same and we are having a sign of multiplication, the power gets added up. So 5 plus 2, 7. Very good. So 1 Newton meter is equal to 10 raised to power 7 dynes multiplied by centimeter. So this is the conversion between SI and CGS units of torque or moment of force. And children, if we talk about gravitation unit, so the unit for the torque can be, it is force into distance. So it can be written as kgf into meter and gram force into centimeter. So what are the units here? The gravitation units of torque can be kgf meter and gram force centimeter.